Hello, I'm Ellie. Today I would like to dive into one aspect of responsible AI called fairness, specifically how it is reported in the Azure Machine Learning Responsible AI dashboard under the error analysis. I want to remind you, I already did a previous video of how to technically get this responsible AI dashboard going using the Azure Machine Learning Pipelines, so you can automate it. And the approach is basically good statistical thinking with the paradigm of responsible AI overlaid. So basically, the way that the dashboard is constructed is that it fits within the regular process of building a predictive model. In old money would call it data mining. So we put in there another step. So after we've modeled and we evaluated the model, we also check whether the model fits within our responsible AI paradigms, and we have applied to it some tests that we can prove that we've given it some thought, which in any case is a good idea to do. Responsible AI covers many different dimensions. As I said, I'm talking about fairness, and the question is, how does one define fairness? One way of saying it is that, I'll take the classical example of being fair to both genders, or to all genders. So no matter what your gender is, you should have the same probability of a particular outcome of, let's say, accepted to a particular loan, or to a particular university. But there's another level, apart from the obvious. The first one was conditional probability. So the probability given that I'm a man should be the same to given that I'm a woman. Equal accuracy is an interesting dimension, and people don't really think about it when we just do Introduction to Statistics 101, which is when I subset my model to subsets of my predictions to subgroups within my data, is my model performing better or less? I mean, probably maybe the probability is the same probability, but the variance around it, the confidence intervals are different. And that is where the error analysis comes in. When you look at the responsible AI examples, practically everybody's using similar data sets. And I really wanted to find a new data set, and I thought that I found a new data set, but I've already seen other people use the same one. So I'll focus on the dropout and academic success data set that comes from this particular URL. I'll link to it below. So how do we measure fairness? Right? So one way, first of all, one can say, I'm fair for every individual, no matter what the characteristics is. So that actually it comes under meritocracy. You can measure it at a group level or at a subgroup level. And the way to measure it is, first of all, we can talk about fit statistics, as I mentioned before. Let's say accuracy, recall, F1 score. We can check whether we're getting the same predictions for the different subgroups or the different individuals. And definitely we can use some causal analysis to say, is this particular variable that's defining a group, let's say gender, does it have an impact on, direct or indirect, on the outcome, taking into account all the system of correlations. So the error analysis is kind of a surrogate to fairness. And if we find that there are patterns within the errors that are linked to the variables that we are concerned, gender, religion, area of residence, height, color of hair, then we should be concerned. The other way around is if I show that I've done an error analysis and the errors are not biased or behave differently for different subgroups, I have something to show a regulator that I've looked into it and this seems to be okay, right? Apart from just not including the variables in the model. So it's easy to say, oh, I won't include gender and religion in the model. It still might be that there are some variables that are correlated to that, causality graphs, that indirectly include bias for color of hair. Obviously, it makes statistical sense to do this, because definitely if you look at the errors for different subsets, then and improve your model, then you're getting better performance in the long run. And obviously, this is a good way to communicate your efforts, your thoughts, and how good the model is. Rather than just giving one number, you look at it also for the key dimensions that define fairness for your organization. So let's look at the Error Explorer. How did they get to it, actually? So basically, we use some training data, we apply a model, we've got predictions, we compare them to the ground truth, and we get an error. The next level that happens for the Error Explorer is, let's take those errors now and make them our target variable and try and see if we can find patterns within the errors, and whether within those patterns the dimensions of concern play a high role or not. And that's all what we will do within this report. Microsoft have built a very nice mechanism to do that. And obviously we use it not on the training data, but we add the validation set to for this particular exercise. So in this case, similarly to the previous video I've done, I did replace one of the analysis with a logistic regression. So I've got already a training data set and a test data set. I run a logistic regression, an LGBM, and just a simple, straightforward classification tree. And then for each one of these, I apply the automation, asking for now just the error analysis. I'm not looking at the other components of the responsible AI dashboard. I'll leave that for a different video. So one of the things I wanted to do, so when you do this, right? When you do this, you say, okay, I would like to omit, generally what we do, right? So people say, don't include gender in your scoring for giving a loan. That's a kind of a standard practice nowadays. So I wanted to omit the gender from the model here when I did the logistic regression, for instance. But then this component here started shouting, well, you're trying to score on a data set that has gender, but your MLflow model does not have gender. Abort. So I said, okay. I'll include it just in the test data set, but not in the train when I do the fit. Still, then it broke over here. The only way I found to do this, so first of all, I have raised it with Microsoft. Let's see what they come back with. What I've done is kind of a hack where when I created the X-train um, matrix to put within my sklearn modeling, I replace the values in the gender column. I keep the gender column, but I just replace everything with the same number. Let's say 0. It doesn't matter what I put there because it's a constant, and definitely it will not play a role. And I definitely checked that the coefficient in logistic regression is 0, and that the importance in the other models is 0. Right? So when you compare these just on the performance side, they seem quite similar, not bad at all. I'll just say that I've done the precision and recall for the positive occurrence of the student has finished the course or is still doing the course. The LGBM has also good statistics, a little bit better than the tree and the logistic regression, also for the prediction and recall of the dropouts. LBGM generally feels better-ish for me. So when you go to the board, and I'll show you in a second how it goes. So you get and you click on this particular eye over there, then you get a little bit information about the board, and here it tells you what you can do with this particular aspect of the board with the error analysis. So you can play with cohorts a little bit, and I'll show you how we do that. Why don't we do that now? So here's my analysis. To get to the board, you can do it two ways. One way is if you go to the gathering of the insights, and over here in the overview, you click open and you'll get the board. Another way is if I go to models and I registered every model under a different name. So you've got the timestamp at the end. So because always I need to have version 1. I discussed that on the previous video. It's a little bit funny that one needs to do it that way, but that's the way it is. So you've got here the model for the tree, the regression, and the LGDM. If I go to the tree and I go all the way to responsible AI, I've got already an entry here, and I can have a look at the board. The first thing that comes up is a report. Remember, this is showing me the errors. This is the error rate over here. So number of observation, 1,328. And the error rate is 23%-ish, about. And I apologize for the gender being false and negative. It should have been 0 and 1, but it's been loaded as false and negative. Women, oh, where did I go? Women have an error rate of 16%, and the model fails more for men. And then it fails more for men's where the tuition is up to date. So there's some information that is kind of missing, I would suggest. To either, first of all, you see it's unbalanced. This is 462 men compared to 866 women. But apart from the fact that it's unbalanced, I would suggest that there's a variable missing to help me identify better, narrow down the error for men. One can ask for the feature list. You can see here that in the tree, the gender is at the top. Now, these are the features that explain the errors. These are not the features that explain that this is not the importance of the variables within the model. This is the importance of the variables within the understanding of the patterns of the errors. And gender is high up there. Therefore, we have in this particular model a significant issue with regards to being biased on gender. No matter if gender, and remember, gender did not play a role at all in the modeling itself. So there's some correlation somewhere hiding within these variables that needs to be investigated further, and we need to decide whether it's within our boundaries or of ethical AI or not. Interesting thing here is you can say, look, I would like you to be a little bit more robust in the analysis and maybe reduce the number of leaves, and please apply it. And it will, because I've attached the compute, it will recalculate it. You can see that it's changed here. And we've got here a situation for a small number of observations. We've got a higher error rate, and that's when the employment rate for the area that they come from is higher than a particular percentage. Very interesting. Now, you can start working with cohorts. So the reports below do not make any sense unless you create some cohorts. So I'll show you how I create a cohort or two. Let's create a cohort of, let's say, +1, meaning I'm in a family of that I've got two adults in the family, and I know that the codes are 2 for married and 5 for cohabiting. And I say just add the filter. I can add other filters. I will save this, and then when I go over here, you can see that I now have the ability to compare the two, and I can actually say, you know what, so please show me the F1 score. So for the +1s, the F1 score is actually better than the general population. Accuracy is not as good. That means that on the recall, it's much better. Okay, so in this case, because it's I can tell you now that actually in the model, there's only one variable that plays a role. Let's go back to the original model here and go to the tree. In the output, you can see that actually only one variable played a role, and that variable 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 is the tuition fees up to date. Is really the only variable that played a role there. So if you look at, let's say, at the logistic regression, I created two different cohorts that were interesting. One of them is women +1, which actually was not a very good cohort to create, but women here have a higher accuracy, and let's add the F1 score. And also the beta on the F1, we've got an issue with men. I can put here the cohort for men also, and now you can compare the two cohorts. And the blue one is the old data, and this one is just women. This one was empty, so it didn't play. And you can compare for different probability groupings, how they fare. Another very interesting capability is the heat map. Let me do it for the LGBM. So if we Here we go, women here. So the LGBM seems to be even better for women. If we go to the, by the way, before we go to the heat map, interesting to look at it from the F1 point of view. I find it a little bit more informative. Again, but the story is the same story, that the model is better generally for women and women that do not have a scholarship than for men who um, have a tuition fee up to date and actually whatever the variable are displaced, not displaced, sorry. Now, if I go to the heat map and I say I would like very much to have a look at gender by marital status, for instance, it generates for me a nice heat map over here where you can see that men that are single have in this case we're showing an F1 score, right? 74 versus 90 for single women. Worst case, well, the moment they're not defined as single, but they are married or cohabiting, um, then the model is uh, less performative, and we don't actually have numbers for these two groups. And for women, um, they've got only one woman here, so it's kind of a no-brainer that it gets it right. So probably we want maybe to combine these groups together into a high level of groupings to get a more robust model from the perspective of the error levels. Um, and interestingly, of course, most students are single, therefore we'll get a better prediction for them. Where was that? This is the married, 3 and 5. Okay, it's low counts. You can actually, once let's say I wanted to have women who are married, sorry, women who are married, remember that please, and cohabiting, you can see it's defined here now in the query, and I can save this as a new cohort to evaluate. So now I've got a tool where I can contrast and compare the different models. If we go back to my presentation, so if you look at the importance, again, this is I was a little bit surprised. Each time I rerun my jobs and I was looking at the variable importance for the arrows, gender, in this case, when I took the screenshot, the gender was down here, but there were other cases where the gender was fourth for logistic regression. For the other two models, the gender is up the top. So we do have an issue. And one of the ways to try and figure out how the things are correlated is to do a causal discovery and do a proper directed graph. And that's already a hint towards how things will, the other elements within the responsible AI are the causality analysis, which I need to deep dive next time. So if we have here our target variable, obviously gender has some weak relationship to the target variable, but when you go through gender and tuition fees up to date, remember that was a variable that played a significant role, especially in the tree. That has a direct relationship, quite strong relationship to the target, and is connected also to this particular variable, delta, and it also has kind of a weak relationship to the target, And the tuition fees also is connected to the scholarship holder. So remember, when we were looking at women, scholarship holder was the next level, and that identified a subset in the pattern for women. Also is connected to the target variable. So the strongest one is actually this one, the 53 here. And interestingly enough, marital status over here has no direct link to the target variable, and actually no direct link to gender, which makes me happy. But it does have some link, not very strong, to the tuition fees up to date. But the strongest link was to the displaced, that has some influence on the tuition fee. So actually, marital status also indirectly affects the tuitions of fees up to date, and together has some maybe relationship to the target variable itself, but not that strong. So I will be less worried about the marital status, and you can see it from the previous analysis that we were talking, but I would be more worried that all the models that I have created, although I did not include gender in them, there's still a pattern of errors that is linked to gender. And it's coming mainly through the tuition fees up to date. And one thing that I could do, one reason is that it's to do with that the data is imbalanced with regards to gender. So I probably need to get more observation, maybe oversample men and undersample women, so I have a balanced design of my data. That's one way, or use a logistic regression that has a special. There's a way when you fit the logistic regression to even in non-balanced situations to take some account of events that are not as prevalent. And another way to do this is to actually try and get people to get to pay up the tuition fees and try and figure out why this is happening. So it's responsible AI is not only about doing models that are fair, but also learning from what the data is telling us about how can we improve our processes. And something around the collection of the tuition fees might be biased. Yeah.